Hi everybody, welcome to this next video. So in this one we're going to be looking at perpendicular lines and we're going to be talking about perpendicular lines in terms of equations of straight lines. So we're going to be looking at the gradients, we're going to be looking at how we find the reciprocals, and then we're going to go on to looking at these things like circles and tangents. This is coming up in the 2022 examination series as we were given the list of topics. So let's jump straight in and have a go. This is for higher students, foundation students won't need to be worrying about this at all. Okay, so line A has the equation 3x plus 4 and line B is perpendicular. Let's quickly just get an idea on what this would look like. So sometimes it helps to just sketch out a graph and see what that would look like if I had it in front of me. So 3x plus 4, the plus 4 is the y-intercept. So let's say that it would be roughly there if each one of these squares had a value of 2. So if that was 2, 4, 6, 8, 10, and a gradient of 3 means I'd go across 1 and up 3, across 1 and up 3. So this line would look something like this, okay? So this would be that line there. Now the perpendicular means at a right angle. So you need to make sure you know what perpendicular means. So perpendicular meaning at a right angle. So the line has to be perpendicular to A and passes through the point 12, 5. So if I assume again that each one of these was 2, 4, 6, 8, 10, 12, and then 2, 4, 5, it passes through this point here. Now the perpendicular to this means it has to go in this direction and it has to create a right angle there. So this purple line is basically what I'm being asked to find. So the process that we follow is this. So y equals 3x plus 4 is the red line. That's our baseline. That's the line we're working from. What you do is you call the gradient, you turn it into a fraction. So 3 becomes 3 over 1. Okay? Now, if it was 5x, it would become 5 over 1, 10x, 10 over 1. It doesn't matter. So anything over 1 is what you do first of all. Okay? Then from here, the key thing we need to find is the reciprocal. So we need to find the reciprocal gradient to that red line. So call the red line our baseline. If I wanted to think about that, that is the line we need to work from. We now need to find the reciprocal of that equation. And to find the reciprocal, you just flip your fraction that you've got, you just flip it upside down. So instead of it being 3 over 1, it now becomes 1 over 3. And then the second thing you have to do is actually then turn it to a negative. Now, if this gradient that you had here was actually negative already, this would become positive. But because this red line is a positive line, this one has to become negative. And that makes sense because in order for the line to pass through it, it has to go in the opposite direction to create a right angle. Otherwise, it wouldn't pass it at a right angle. So we say that this purple line has the gradient y equals minus a third of x, so the minus a third of x is a gradient, plus c. And the plus c refers to this point here. Okay, that's your plus c, that's your y-intercept. I don't know where it crosses the y-axis. So we found our gradient, and we've done that through flipping the gradient of the first line. Now I need to find the y-intercept. Okay, if you're unsure on y-intercept and gradients and things like that, it might be worth you going back and looking at the video I've done on equations of straight line graphs. So how do I now work this out? Well, I've got a key point that I know, and that's this bit here. This 12,5 is really important. This 12,5 has to sit on this purple line. So then the next thing you need to think about doing is substituting those values into here. So this step 2 would be substitute values into the reciprocal. So this is my x value, and this is my y value. So x is 12, y is 5. So all I do is I take that 5 and change y for 5. Minus a third. Now remember that minus a third of x means minus a third times by x. So I times that by what I've got here, which is 12. So times 12, and then plus c. Now, keeping this all in fractions makes this a lot easier to work with. So I can call that 12 over 1. And then that becomes, when you're multiplying with fractions, you multiply top by top, bottom by bottom. So that just becomes minus 12 over 3 plus c is 5. Now, that's an improper fraction. So how many times is 3 going to 12? Well, it's 4. So that actually becomes minus 4. So 5 is equal to minus 4 plus c. And now you're in a position where we need to isolate c. So you need to find the value of c here. So this plus 4 goes over, minus 4, sorry, goes over. It becomes a plus 4. So we end up with 5 plus 4 is equal to c. So c is equal to 9. And then what I do is I take that c and I go back up here and I replace that for c. So I say the equation of the purple line is y equals minus a third of x and then plus 9. And that, if you look at this graph, does make sense. This value here was 4, this is 6, this is 8. Looks roughly about right that it should be at the positive value of 9 to fit in line with that one. Okay, so just a quick recap. First thing you do, find the gradient of the initial line, your baseline that you want to look at, and that's given to me in this one. Sometimes this won't be given to you, and we'll look at examples of that in a minute. Then you flip it upside down. So change the turn it to a fraction, flip it upside down, and if it's already positive, turn it negative. Once you've then got that, you take your values that you've been given in the question and substitute into this perpendicular equation, rearrange it to isolate c, and then chuck that c back into your original equation, put it all together. Okay, so looking at this example here now, a little bit harder because you've not been given the actual gradient. Okay, so you've not been given the gradient of line A now, but you've been given 2 coordinates. So what you can do here, so you can have a go at this, you can pause the video and have a go first of all. You need to find the gradient of this line. Okay, and the way you do that, finding gradient, again, if you haven't watched the previous video I did on it, it's change in y divided by change in x. And what I mean by change in y is that's your y coordinate, that's your y coordinate, so what's your change there? And then your x coordinate is 5 and 7, what's your change there? That will give you the gradient of A, and then you can work the rest out from there. So if you want to have a go, pause the video, have a go at this one now, and then I'll go through it. Okay, let's visualize it again. So 5, 6. So 5, 6 would be roughly there, and then 7, 16 would be a lot higher. It'd probably be somewhere up here. 2, 4, 6, 8, 10, 12. Sorry, it'd be there. Ignore the fact that it goes through the writing. So this initial line would look probably something like this. Okay, let's move that down so it doesn't cross through the writing for you guys. So that's my initial line. So I need to find the gradient of that. So the first thing I do then is I say y is equal to change in y. Well, the change in y is between 6 to 16, so that's 10. And my change in x is from 5 to 7, which is 2. So the gradient of this line is 5x. Now, I don't need to know the y-intercept of this line. Okay, the y-intercept would be somewhere down here. That's actually not important for this question. So I can just leave it as y equals 5x plus c. This would get you a mark in an exam. From here, remember, we turn it into 5 over 1 of x plus c. And then we go reciprocal. And the reciprocal, in this instance, therefore becomes y equals minus a fifth of x plus c. That would be a second mark that you would pick up. So I'm finding this line that now goes through the point 10, 2. So goes through this point here and crosses that line at a right angle, which means it probably looks something like this. Probably be a bit flatter than that. It's not a perfect right angle, but it looks something like that. So now let's substitute in these values that we know. So remember that this 10 is your x and this 2 is your y. So I change y for 2 is equal to minus a fifth. Remember, minus a fifth of x means times x, and we're saying x is 10, so times 10 plus c, change that 10 to 10 over 1, minus 1, so we times top by top, bottom by bottom, so it becomes minus 10 over 5. Well, minus 10 over 5 is actually just minus 2. And now, remember what we did previously, you need to isolate this c, so the minus 2 goes over, and it becomes a plus 2. So we're saying 2 plus 2 is equal to c, so c is equal to 4. Take that 4, go back up here, and we say y is equal to minus a fifth of x, that's your gradient for the purple line, plus 4. And again, that looks about right, it would pass through that point there. So if I was to redraw that purple line so it works going through the correct points, that looks much better, and that actually is your right angle. So that'd be your answer. Okay, so there's a couple of different examples. First one, you're given the gradient of the initial line. Second one, you've got to find the gradient of the initial line. So it's worth knowing how to do that using that equation up there, changing y divided by changing x. Okay, so the next thing we're going to look at is more of a grade 9 topic. We're looking at the perpendicular lines and how you find the equation of this perpendicular line when you're given an equation of a circle, okay, and points on a circle. So that's the next thing we're going to look through. So let's break down what we've got here, put it all together and see what we end up with. So line A is a tangent to the circle. So this is line A here. This is the line we're talking about. It is a tangent to the circle, which therefore means if anything is a tangent to the circle, if I was to then draw this line here, which is the radius, I know that that creates a right angle because of our circle theorem rules. So that's your first concept that will allow you to understand why you need to be using perpendicular lines in this question. So the tangent line is here, and therefore when I create a line that is the radius of a circle, when a radius meets a tangent, it creates a right angle, and therefore these two lines are perpendicular. Point P is 8, 10, so there's my x value, there's my y value, and it's on the circumference of the circle, so I know that this line passes through that point because it's on the circumference. Find the equation of A. So I've got to find the equation of this line. Now, let's go back to what we were doing at the start. The first thing I'm going to need to find is if I want to find the equation of this perpendicular, I'm going to need to find the equation of this line here first of all. So this red line is what I need to find. And this goes back to change in y divided by change in x. By doing that, that will give me the gradient of that red line. Now, I can find that because actually if I do this and create a triangle here, I know that these two values here are part of what I'm looking at. This point here starts at 0, 0, and this point here is at 8, 10, which means my x value is 8, my y value is actually going to be 10 there, because to get this point you go 8 across and 10 up. So from using that information, I can actually then say, well, my change in y is 10 and my change in x is 8. So my gradient is 10 over 8. If you wanted to simplify that, you could call that 5 over 4, because you're obviously dividing both of those by 2. So for that red line, I can say the equation is y equals 5 over 4x, okay? And it passes through the origin, so effectively it's plus 0, but because it's plus 0, it's irrelevant, don't need to write it. So that's the equation of that red line. So now, if we're looking at the perpendicular line, which is this one here, I'm going to do this in purple. So now if we're trying to find that perpendicular line, go back to what we did before, the first thing we need to find is the reciprocal. So the reciprocal of 5 over 4 of x would be y equals minus 4 over 5 of x plus c. We obviously don't know what the y-intercept is. I don't know this point up here where it crosses, and that's what I've now got to find. So the first thing you do is find that reciprocal, which flip that equation upside down here, flip that gradient upside down, which is what I've just done. Now what you need to do is I need to find c. Because I know it passes through this point here, which is 8, 10, I can substitute those values into this equation. So I know y is 10, so change y for 10, minus 4 fifths, and remember minus 4 fifths of x means minus 4 fifths times by x, and my x is 8, so times 8 plus c. Now we can leave this as a fraction. So it becomes minus 4/5 times 8 over 1, which then turns to minus 4 times 8, which is 32, over 5, plus c. Now, and that's 10. From this point, you could start to turn this into a decimal if you wanted to. So you could write this as 10 is equal to, how many times does 5 go into 32? Well, it's 6 times, and then 2 left over, and that's 2 over 5. Or you could write that as 0.4 plus c. So we're saying 10 is equal to minus 6.4 plus c. Or, and then what I do, is I go, right, that needs to come over this side. So because it's minus 6.4, when I move it, it becomes plus 6.4 is equal to c. So c is equal to 16.4. Take that, substitute it back up here, and your final equation therefore becomes y is equal to minus 4/5 of x plus 16.4. And that is the equation of that purple perpendicular line. Okay, so that would be your process for finding the equation of a tangent to a circle. So one more example for you now to have a go at is here. So if you want to pause the video and have a go at it straight away yourself, you can. I'm going to give you a starting process and then you can work from there if you want to. First thing to identify is that when it has x squared plus y squared equals 25, basically if you square root the 25, that gives you your radius. Okay, so in a circle, in the equation of a circle, if it's x squared plus y squared equals something, if you square root the end value, that will give you your radius. So what I know in this case here is that this point is 5. Okay, so that is your radius for this circle. Now the next thing it tells me is that the point on the circumference has minus 4y. So this point here is minus 4y. Now what that means is I'm effectively going back 4 here, so that's a coordinate of minus 4, and then you've got to go up something there. Now what you've actually got here is a triangle, which can be used as a Pythagorean triangle. So we're saying minus 4, which is my x, but I'm not going to use a negative for now because I'm just going to treat it like a triangle instead of coordinate, plus b squared, so a squared plus b squared equals your c squared, and in this case the c squared is 5. So we're saying 16 plus something squared equals 25, and that therefore has to be 3 squared because it's got to make 9. So this value here is actually 3. So the coordinates at that point are minus 4, 3, because we know we're going 4 back and then 3 up here, because it has to make a correct triangle using Pythagoras. So that can be your starting point. If you're a little bit stuck on that, that is your starting point. So if you do want to pause the video now and have a go, you can have a go at working it out. So I'm still going to need to do change in y divided by change in x for my red line here. Okay, so my change in y is 3 and my change in x is now minus 4, which means I'm going to end up with a negative gradient. So the equation of that blue line is y equals minus 3 over 4x. So, and it passes through the origin, so it'd be plus 0 effectively. So y equals minus 3/4 of x is your equation of that line there. Then from here, what we now need to do is find the reciprocal to find this purple line that goes up here. So we're saying y is equal to, it now becomes a positive, okay, because in the first instance here that's negative, it now becomes positive, 4 over 3x plus c, we don't know what c is. And now I'm going to substitute in the values I know. I know that y is now 3, so 3 is equal to 4/3 times by x. Now be careful here, x is minus 4, so it's minus 4 plus c. Put that as over 1, and you end up with minus 16, because you're doing top times top, bottom times bottom, over 3 plus c. Now, minus 16 over 3 is actually, let's come over here a little bit, minus 16 over 3 is actually 5.3 reoccurring, okay, but obviously it's minus 5.3 reoccurring, and so therefore I'm trying to get c on its own. I now take that over this side, and it becomes 3 plus 5.3 reoccurring, which gives you c. So therefore C is equal to 8.3 reoccurring. And you take that value and substitute it back into your initial equation. So you're saying Y is equal to 4/3 of X. Remember, it's positive because the line's going up now. And then plus 8.3 reoccurring. Now, if you left your answer as a fraction as well, that would be okay. But that is the equation of that line. So that's our equation of perpendicular lines, and then perpendicular lines when there's a circle involved with a tangent. Hope you found that video useful. It might be worth going back over a couple of bits there that you're not 100% sure on, because it is a complex topic, especially these last bits which are grade 9. Hope you found that useful, and I'll see you all in the next video.